Welcome, everybody. Thank you for joining the Arkieva webinar. Today, we're going to be discussing 3 must-have inventory management software features for optimizing your S&OP process today. And this is going to be the concluding part of our webinar series that has been on inventory optimization. For this part of the webinar, we're going to focus on inventory planning, and our discussion is going to be centered on managing inventory to target and capacity. My name is Helen Otiabo. I'm the marketing manager at Arkieva, and I'll be moderating this webinar. Today, I have with me, once again, Arkieva COO, Sujit Singh.
Hello.
Nice to have you here, Sujit. Thanks for spending time with us.
Absolutely.
So a few things before we get started. If at any point in time you have trouble hearing us, please let us know, and we'll be sure to assist you. Also, at the end of the survey, we like to get some feedback from you. So if you can fill out the survey, we'll really appreciate it. So as I mentioned previously, this is part of our 3-part webinar series where we've been talking about the software features needed for inventory optimization. The first part, we started off talking about inventory visibility, analytics, how do you set the right policies so that you can have inventory that's optimal. Next, we moved on and we started talking about safety stock optimization. So today we're going to focus on, once you have the inventory targets in place, how do you go about planning, looking at the capacity constraints that you have? And all of this can be found on our website. We have our recordings, so feel free to check it out. So what's the agenda for today? As I mentioned previously, today we're going to focus on inventory planning. We're going to go through the exercise with looking at one product with RCCP techniques. And what that's going to help us do is we're going to look at some decisions and effects of those decisions. And we're going to realize at the end of it all that that might be too cumbersome. It might be too much work trying to do that with RCCP. So as a result of that, we're going to look at some alternatives as well. And this is going to be a rule-based engine or optimized-based engine. Now, I think the interesting thing to note about Arkieva, since we have some people here that are meeting us for the first time, I thought it was optimal to introduce the company. We've been in business since 1993. So this is going to be our 25th anniversary. We have a single supply chain focus. We're not an ERP company or system. But what we do is purely supply chain planning. So we focus on ways to help you improve your planning processes so that you can be more profitable, optimize your processes, and have a better supply chain in place. And now to be able to do that, we have a full solution suite, which starts off with segmentation all the way to help you get the right supply chain visibility with the right dashboards and reporting. Today, we're going to focus on supply chain planning and capacity planning. Our RCCP and supply chain optimization kind of falls under that category. And now to start up the discussion, we're going to look at this question with how do you manage inventory between the minimum and the maximum targets? And now I'm going to turn it over to Sujit, who'll start the discussion.
Thank you, Helen. All right, so let's jump right into it. The question that Helen has posed is, how do we manage the inventory between the minimum and the maximum targets? So obviously, we are making an assumption. And the assumption is that either you have watched the first 2 parts of this webinar series, or you're just in general familiar with the idea of setting up targets, be as it may around safety stocks or cycle stocks, and using those calculations to set your minimums and the maximums on a per item or a per product family basis. Now, this is a whole science in itself. And, we certainly invite you to watch the recording of the webinar, the second webinar, if you haven't done so. We'll give you some insights into that. So here, we are going to assume that that all has been accomplished in your business and you're ready to manage to those targets. So with that said, let us look at a quick pictorial here. The blue line at the bottom represents the hard work that is used to generate the minimum target in your company, and the orange line on the top is the maximum. And then if we look at the green line, that is supposed to indicate the projected inventory as the supply chain's pluses and minuses go through the system. As demand comes in, as production comes in, purchase comes in, supply comes in, where would that ending inventory at the end of each month show up? So if we look at this example, in January and February and March and April, we are well within the range, acceptable range of the minimum and the maximum. Right in June, we go outside that bound. We basically pierce that boundary. We are above the max target. Then we begin to, in terms of our projected inventory, we begin to work it down. And then by the time we are in August, we again go out of the minimum target range, which we then again work to correct it, and so on and so forth. Now, this can represent the life cycle of any company at a global level. It can also very easily represent the life cycle of the inventory at a particular product or a product family level. Every time a company goes above or below the required or desired target, they make adjustments to bring it more in control. So how do we manage that? That's what we are going to talk about. Now, one easy way to manage this, certainly if you have what I would call less complex supply chain operations, is a technique called rough cut capacity planning, which is also known as RCCP. And so this idea is that we are going to do some very rough calculations, directionally correct, but do not necessarily involve all the levels of detail. And we'll try to use that to manage our future outlook of the inventory. So what we'll do is we'll look at an example. Let's imagine that coffee mugs are being produced and then they are being packaged. And we would like to manage the inventory of these coffee mugs as well as the capacity on the packaging operation. Now, rough cut capacity planning is typically done in Microsoft Excel. As planners, maybe you have made spreadsheets that represent this rough cut plan. For today's discussion, I've taken the liberty of using the Arkieva interface just to give you a couple of examples. The interface does look like Excel by design because rough cut planning, the users are typically coming from that Excel background. So as you will see, it does look like Excel. So let's look at this example. I'm going to skip out of the software, the slide deck, and go to the software. So here is the screen that represents the rough cut capacity planning. And as I said, the top section here is very Excel-like. And if you have ever built a rough cut capacity planning Excel spreadsheet, you would have probably got these kinds of rows in it. It's got beginning inventory, the demand as it pertains to forecast and orders, the production, any dependent demand, any purchases or procurement, and the resulting ending inventory. Now in this screen, I do have demand, but I do not have any supply. So as a result, my starting inventory is of 59,000 units. And as the demand is eating up that inventory, you can see that my ending inventory goes more and more and more negative through this time horizon. Now I've done a little trick in the background. I've selected just one product, the coffee mug. And if I show you a little bit further down, here's that packaging line that is supposed to package the coffee mugs. And right now, because there is no production on that line, the total capacity usage is 0%. All right. So with that picture, you can almost call it the default download of the data with almost a blank slate in terms of the supply. A planner might want to have some very simple calculations around starting things off on how much to produce. So we have a button here, create default production. You might do it using Excel macros and so on. The idea is very simple. Let's make a quick and easy calculation to see how much to make so that we are within the range of the target. So I'm going to go ahead and click this button. It asks me in what range do I want to create this default production. And as I do that, boom, you can see that now I have production in every single month. As a result, you will notice that the inventory numbers that were in red in color are no longer red. And in fact, the ending inventory in every period, because it's a simple calculator, it tries to bring it inside the targets, is exactly 59,605 units, which happens to be very nicely inside the minimum and maximum range. So we are exactly where we would like to be by using this default production button as it pertains to being inside the minimum and the maximum inventory targets. However, there is an issue that is created, or certainly there is a potential of an issue. So if we scroll down and look at the capacity picture of the packaging line, what you will notice is that in the month of April, which corresponds to the month here, in the month of April, the system, because of the default production that we have created, is going to use more than 100% of the capacity available, which obviously is not possible. In the month of March, the prior month, we have about 91% capacity usage, and in the month of May, we have 78% capacity usage. So if I were to think about resolving this problem in April, I have some potential of moving production either to March or to May. Also worth noting is the very first period where the capacity usage is 115%. Now, I'm not going to focus on that. Most rough cut planning engines will assume that the very beginning of the horizon is somewhat frozen, and they will probably not want to tweak it. So we'll just worry about April for right now. So what we will do is we will quickly see this in a pictorial form. So here is a slide that represents the minimum target in orange color, the maximum target in the gray color, and the blue line is, just like we saw on that Excel sheet, is representing very nicely for us that our inventory in this horizon, after we have created the default production, is very nicely within that band, exactly where one would like it. And then if I go to the next slide, it shows us that the orange line represents the 100% usage of the capacity. And as you can see, in the month of April, we are above that capacity limit. So, and that is by about 20%. And it also shows us that in March and in May, we are not using all the capacity. So just to put a little exclamation on it, the red is where we have the trouble. The dark green, which is the month of March, there's an opportunity to adjust some of the production because there's some capacity left over. The second opportunity is in May. The light green color on May, as opposed to the slightly darker green on March, is simply representing the fact that if we move April's production to May, we might actually be in a position where we cannot meet all the demand on time. So that's why it's less optimal to move it to May compared to moving it to March. All right. So if I'm the planner and I'm looking at this default production, I might say, well, capacity is kind of a hard limit. I cannot really breach it. I would like to adjust my plan. So I might consider options that might be available to me. And here, one of the obvious options, is to move production to an earlier period where capacity is available. So in our case, because April is the one that is overloaded, we have the option of moving things to March. Now, the other questions that might come up with this is by how much amount should we move? And, if you are in a business where age of the product matters, you might have things to consider like how early can I really move it? Can I really make product, 2-3 months in advance? Sometimes that might not be possible. So let's say in this fictitious example, the planner makes a decision and they are going to move 30,000 units of production from April to March. So let us again look at this from the point of view of the software. So let us come down to the screen where we have all the production detail. And here, if I may just sort this by time, we can see that in the month of February, the system had suggested a default production of 150,000 and change. March was 131,000 and change, and April was 169,000 and change. Now, the decision that we just saw on the slide was to decrease or to move about 30,000 units from April into March. So the way you would do that is you would just change this 169,000 to 139,000. That represents a 30,000 reduction in the production in the month of April. Now, when you click out, the system understands that as a change, and it immediately calculates the capacity usage in the month of April. We were red a second ago. Now we are just about, at the edge of the boundary, which is not, and so we are now going to use only 99.5% of the capacity. So just close enough, let's say. And then in the month of March, the total right now is 131,000. Because we took out 30,000 from the month of April, we'll increase March by 30,000. And so 131,000 will become 161,000. And as we do that, immediately we now notice that the capacity usage in the month of March has gone up from 91% to 111%. So in a way, we have fixed a problem and we have created a new one. Let's again look at it in terms of a graph. So, this is the classic, and anyone who has done any supply chain planning knows this idea of you zig, I zag. You move something in one place, it has an effect somewhere else. So here, we were looking at a problem in the month of April. That's what is indicated by the red arrow. And obviously, the problem being that we were above 100% capacity usage. Now, that has just shifted to the month of March. So April's woes have shifted to March. And that's obviously going to be an issue. Now, before we fix this problem, let's also look at the target. Because we are making a lot more in March, sure enough, the ending inventory in the month of March is above the target. So in a way, if we are able to make that 30,000 in the month of March, if the capacity was not an issue, well, in that case, we would end the month of March above the maximum target, and then, in the next month, we would consume that product, and we'll go down to where we would like it to be. So obviously, capacity being a hard constraint, this is not going to be an acceptable result for a planner. And then they might say, well, what are my other options? So let's recall that earlier we had seen that when April was using too much capacity, we had options available in March as well as in May, with May being the secondary or second preference in terms of the option. That's what I had indicated by the use of a lighter green color. So this is now saying that since moving 30,000 units of production to March creates a problem in March, maybe we should move a little bit to March and allow a little bit to be moving towards May. So if we were to do that, so let's make a different decision. The planner decision number 2 is that let's move only 10,000 from April to March and move the remaining 20,000 to May. Now, let's also not kid ourselves. This may result in delayed fulfillment of the demand, but let's just for now say this is the decision. Let's see how this looks like, what this looks like in the software or in the RCCP. So if we again go back, now recall that we were looking at March, and I had increased it by 30,000. So now the new decision is, well, maybe March should only be increased by 10,000. So I'm going to, since I had increased it by 30,000 earlier, I'll do the quick math and now reduce this by 20,000. So now I make this 141,000. And as I do that and I click outside, my capacity usage in the month of March has now dropped to 98%, which is a good thing. I'm right under the 100% limit, which is a real limit. And then I go to the month of May, which is right here. The May production is 112,000. I'm going to increase this by 20,000 units. So I'm going to make this 132,000 and change. And as I do that, right now, May's capacity usage is 78%. When I click out, it goes up to 91.95%. So now we are taking the April month, which was overloaded. We have moved some production to March. We moved some production to April. Immediately, one should question, did we make any demand late? Well, it turns out we really did not, because we had enough inventory. So you will notice here there are things which say demand met on time and demand met late and so on. Well, really, it did not have an impact on the demand, the meeting of the demand. Sure enough, the ending inventory in the month of April has now dropped to 39,000, which is less than the minimum target of 48,000. So in a way, the problem that we have is that we are ending the month of April below the target. Let's switch back to the slide. So what does this mean? Well, it seems that we have sorted out the capacity issues. All our capacity numbers are below 100%, except for that first month, which I said we will not try to tackle because of the idea of a frozen zone. And inventory, sure enough, is going below the target, below the minimum target, which is okay. Why is it okay? Because, well, all demand is still being met. So we have gone through a very simple example. We have taken a fictitious company that packages coffee mugs, and the packaging line has a capacity limit, and we have some targets that we have established, and we have gone through a planning sequence of decision making of really 2, maybe 3 decisions, and we have seen the impact of that. So let's summarize that. To solve one simple problem of overcapacity use in 1 month of April, we had to go through 3 moves. First move was to move it to March. Then second move was to move part of it to March. And the third move was to move part of it to May. So 3 moves to solve one problem at one product level for one production unit. Very manual. I had to think through how much should I move up, how much should I move down, what is the impact. So it was a very manual step. And it was very dependent on my knowledge and my attention around what are the things that play with each other. Even though in our example we used only one product, if we had tens of products that were all being run on that packaging line, just moving the production of one product might not have solved the issue. We might have to move production of multiple products. So it's really dependent on the knowledge and the attention of the planner to the entire landscape. Now, imagine this situation where you had to consider even advanced options, such as there were 2 packaging lines and you wanted to move production from one resource to another. That would require a lot more thinking. If you had to decide that there's no way you could meet all that demand, you would have to decide which demand you were not going to meet in that sequence. If you had to add a capacity, let's say that was an option, that you could add a shift, where would you add it? Where would you not add it? So these are some advanced options that we did not even consider in our example. In fact, we worked a very, very simple series of steps on one product and one production line. So as you can imagine, in order for us to consider more advanced options, it will require more thinking, more knowledge, and maybe a more robust Excel sheet with a lot more formulas built in. Over time, what we have seen is that rough cut capacity planning has a limit. There's a particular limit up to which planners can play with that result, and beyond that, it becomes too much work, and they cannot then continue to do their planning using rough cut. So in this manual mode, once they reach that limit, they begin to yearn for something else, and that something else typically is either writing a little macro in Excel to do the plan for them, or by what we call engine-based supply planning systems. So let's look at some of that. So typical RCCP deployment is done in Excel. There's a lot of time spent in data import or input. And because it's so much manual work, it's almost impossible to do it at a very detailed, so for example, an SKU kind of level. So very often you would see it being done at a product family level. Very often you will see that people assume infinite capacity and then move things around to kind of make it more executable. And one would argue it is limited in the value it creates. certainly the effort required to create the value can be quite high as well. So the delta can be limited. Oh, so very often companies will reach a point beyond which they can no longer use the RCCP and they'll move on to the next step. If you happen to be in the stage where you continue to get value out of RCCP, then the one recommendation that we would make in terms of improving that part of the process is to import what can be, or rather automate what can be automated. For example, a lot of time is spent in these RCCP spreadsheets in copying data from the source files. And Excel, to the extent you know how to do this in Excel, if you can automate these data import steps, you'll make your job that much easier. So that might be an idea for improvement if you decide that RCCP is the tool that you would like to continue with. For others who have reached that breaking point where they say, this is just too much work, I'm pulling my hair out, I just cannot remember, the so many options that are available, or as one of my customer puts it, it's like a giant balloon. I try to control it by pushing on one side and it bulges out totally on the other side, and I don't even know where it's bulging out. Well, in all these situations, you might have reached a point where RCCP will simply not cut it for you, and then maybe you are ready to move to the next step of planning. Typically, for a lot of companies, the next step is a rule-based engine. And so what is a rule-based engine? Well, in a nutshell, a rule-based engine is something that is going to do your supply planning for you in a very prescribed sequence. So prescribed sequence could be first do this, then do that. Very often we will see these rule-based sequences being executed by planners as part of a process, like they might work some things in one worksheet, then go to the next worksheet. And so that is their sequence. When you try to automate it, the very first time they would do it could be in a macro inside of an Excel file. And then, of course, you can buy a rule-based engine from the marketplace. Many of them are available, including one from Arkieva. So when we give an example or think of an example of first this, then that, here, we might say in a rule-based engine, we might want to first satisfy all our demand that is coming from orders from customers. Then and only then we want to look at satisfying the forecast. And then only then at the end of that, we might want to satisfy our inventory targets. That might be a sequence of rules that a company might be interested in terms of how to make the production available to the supply chain. Orders first, forecast next, inventory targets last. And, even further down from there, they might say, well, when it comes to orders, maybe prioritized by this customer sequence. This customer is a very high priority. They buy, a big chunk from us. We want to give their orders the highest priority. And so we might want to follow a customer priority when we prioritize our different orders. We might have rules around, well, when we have capacity shortage, which demand should be satisfied first, and which demand can really be ignored from satisfying process. So these are some examples of rules. Now, whenever you move from RCCP to any engine, and we'll talk about an optimization-based engine in a little bit, but whenever you move to any engine, one thing to remember is this is a very data-intensive exercise. One reason why RCCP is so popular is that it sometimes can be overbearing to do all the data integration needed to do these proper supply planning. So what do I mean by that? Well, let's look at a generic material flow in any, what you would call run-of-the-mill supply chain. So if you look in this schematic from left to right, we have raw material suppliers providing raw materials to plants or the production facilities, which then make some things. And once they make those things, they move them further on downstream to warehouses. And from those warehouses, the product goes to the customer. So these arrows represent that material flow from left to right. We are getting it from raw materials, doing something to it, moving it to warehouse, and then eventually giving it to the customer who hopefully has a good need for that particular product. At each stage of this network, there is very intensive data requirement when it comes to supply planning. So raw material suppliers might need to tell us the prices, the minimums that they can supply, the maximums that they can supply. Plants might need to tell us things like capacity information, when will we shut down, when will we, what are the production rates, those types of things. We have warehouses. They might be needing to tell us things like how much can we store, what the targets are. Customers might need to tell us what their demand looks like, what their source preferences, if any, looks like, what are the selling prices. And if we are moving product across locations, we also probably need to know things like lead times and minimums and maximums. As you can imagine, and by the way, this is by no means a full picture of all the data needed, but even with this not complete picture, you can see there's a lot of different types of data that is needed to do effective supply planning. That is why RCCP remains so popular, because you can circumvent a lot of this integration and just type in some numbers in Excel, which at one level wastes some time, but at least it allows you to get started very quickly. Anyway, so continuing with this theme of data intensity, these data fields can come from multiple sources. You might have an ERP system, you might have some Excel sheets which have some of the data. Sometimes the data might simply reside in the planner's heads, and we might have to actually give them a place where they can type it in. So a lot of different sources of this data can exist, and if you are even a little bit serious about doing supply planning, you will have to build some integration to get all this data into some central spot from where you can then proceed to do the supply chain or supply planning. And whether you call it a data repository, data mart, a database, doesn't really matter, but some place where you can consolidate all this data is a prerequisite before we can do any kind of supply planning. So once we have all this data, the data links are built in. Planners can either update this data in batch mode, like overnight, or maybe on demand during the day. Then they solve the model, analyze the results, and then distribute it via the S&OP process. So when we say solve the model, what we are really talking about is what we saw earlier in the RCCP screens. The decisions that we were making, move a little bit to March. Well, that didn't work. Move it a little bit to March and then rest to May. All those decisions are in that solve the model step. Given your rules, given your priority sequence, the engine is going to make those decisions for you. So as long as the engine is configured properly, you can imagine it reduces the workload on the planner, and it also makes, hopefully, better decisions, more predictable decisions for you, because once you have coded, sure, in the beginning there might be issues, but once you have sorted out all the issues, the model will be more predictable, and it will follow your priority sequence in a better way. So it's a big jump to go from the manual process and doing maybe 500 of these thought processes every month to just uploading the data, having the rules coded in once, and then you click the button and it does it for you. So it is a major advance to go from RCCP to any rule-based engine. So the slides that we were looking at earlier, where we were actually manually moving things around, now become a direct output of the model. So here's the screen where, without doing much, you click the button and it comes out and it says, well, here's the target and here's what the ending inventory should look like. And then if you don't like the results, you will obviously spend a little bit of time tweaking the results, but eventually you should be able to hit the targets exactly. As you can see in this schematic, the ending inventory matches the target inventory exactly, because that's the rule we have provided to it. So you have a lot more control on a model once you know how to use it. All right, so we have looked at RCCP, which was the very manual process. Then we have looked at a rule-based engine, which kind of advances the ball a little bit further downfield. But what is to say that the rules that we have come up are the best ones? So in other words, I'm going to say, what if the rules themselves are suboptimal? And obviously, we might look at a couple of examples. So here is an example where product is being moved from Wilmington to a warehouse in Singapore, and then the warehouse in Singapore is then moving it downstream to Jakarta, Shanghai, and Saigon. Well, let's say the rule says that product can only flow from left to right. How does that system then also consider rebalancing the inventory in the quote-unquote area? So in this area, geographically speaking, Jakarta, Shanghai, Saigon, they are reasonably close to each other. Moving product from Wilmington all the way downstream is a much more expensive affair compared to just moving the product across these three warehouses. So how do we rebalance that inventory? Well, if you have too much inventory in Jakarta, a different way to ask that same question. If you have too much inventory in Jakarta and Saigon needs the product, how do we tell a rule-based model to move that inventory from Jakarta to Saigon as opposed to, for example, moving it from Wilmington to Singapore and then from Singapore to Saigon? Sometimes these rule-based systems, because they follow a particular sequence, can be limited in how they manage that. This is not to say that they cannot be tweaked to follow the new rule, but it's just that you can sometimes get into a mode where you are constantly adding more and more and more rules. If you find yourself in that situation, you might say the rule-based system is not going to be good enough for me. Let's look at another example. Let's say the rule-based system is prioritizing a particular kind of demand. So let's say it's making a particular kind of coffee mug that it so happens let's say it's a flimsy or fragile product, and packaging it is a really complex operation. So you have to do it really, really carefully. Well, let's say that also happens to be a higher priority product as far as your supply chain is concerned. And let's say by contrast, you have a different product, it's a slightly lower priority, but it's really fast to make. It's really easy to make that product. A rule-based system will follow that priority religiously almost and will follow your sequence, and sometimes that can be to your detriment. Sometimes avoiding the preference of the priority and going around and making the faster, lower priority product can make your company a lot more money simply because of the fact that you will be making a lot more of that product. So this is another example where a rule-based system can sometimes get bogged down by its own rules. So if you find yourself in these types of situations, you might want to consider using an optimization-based model. So the optimization-based model is particularly useful when there are many choices in the system. I've listed some examples here. Certainly the examples we just looked at as limitations of the rule-based system can also be reasons to move into the optimization network. Whenever you have a lot of choices such that your rules can sometimes contradict what is best for the company, you might want to consider optimizing your network. So if we are strictly in the engines frame, we are moved along from the rough cut mode, and we are definitely looking to consider the two different types of engines. It's important to know what are the differences. So a rule-based engine, it tries to mimic the planner's thought process. It tries to mimic or follow a priority sequence, and it's a left to right, top to bottom approach. So in a way, it's not truly optimal, but in many cases, it's more than good enough. Optimization, on the other hand, is a different kind of a calculator. It tries to follow an overall direction or an objective. For example, the objective could be maximize the profit of this enterprise. And in that case, it's going to make decisions that optimize or maximize that particular objective. It is a simultaneous solver of equations, whereas rule-based ones follows a sequence. This one tries to solve all the equations in one go so that it gives you the most optimal or truly optimal results. So in a way, it provides what is the best for the business given the current situation. Both engines have their pluses and minuses. Certainly both engines enable what if or scenario type of planning, because once you build a model, you can tweak certain inputs and then get different kinds of outputs. So both engines have their own power, and if you are finding yourself in a position to try to figure out which one to pick, some things to look at in your decision criteria could be your time horizon. How long of a plan are you interested in running? Time buckets, are you looking at days and weeks, or weeks and months, or quarters? What is the level of detail that you are interested in? Are you wanting to do things by SKU or by product family? What's the number of choices? This is probably the biggest differentiator. If there are many, many, many choices in your supply chain, probably a rule-based system will find a breaking point. And so in that case, you might have no choice but to go towards an optimizer. And ultimately, what is the desired solution characteristic? Are you looking for a so-called optimal solution, or are you more interested in automating what your planner does? Are you more interested in mimicking their actions? If the latter, go towards a rule-based system. If the former, go towards an optimization-based system. So those are some of the criteria with which you might go into the so-called battlefield of deciding which way to go, which one to choose, which one to pick. If you have moved on from or graduated from the RCCP world, if that is no longer working for you, then you have a choice which type of an engine you go for, and these might be some criteria that you use to determine, which tool to go with. So let's summarize. We have been at it for close to 40 minutes now. Let's say that, it might sound easy, but managing the inventory to targets is a cumbersome and a complex task, and it requires a lot of effort and sometimes tools. Typically, you need a model that represents the business. The one caution I would give here is the model does not need to be perfect. It needs to be good enough so that it represents the business decisions that you're going to take. Sometimes in these types of models, perfection can be just unachievable, but you can easily make a model that represents the business in a good enough way that you can determine the right or drive the right decisions from that model. If your business is not too complex, an Excel-based or some other technology-based rough cut capacity planning approach might very well be enough. So you should really consider that. But if you have found that you have moved past that, then you need to carefully evaluate either a rule-based or an optimization-based system, and then hopefully you can use that engine to drive your supply planning much better. So with that, I will turn this back to Helen.
Thank you, Sujit. I think that was very insightful. We've learned quite a lot from this webinar series. Even though this concludes our webinar series on inventory optimization software features, this shouldn't necessarily be the end of the conversation. If you want to see a more tailored demonstration, you can go to our website and ask for a demo, or you can email me at the email shown on your screen, and I'll be happy to facilitate that. We're going to open this up to questions, so if you have questions, please feel free to use the questions window in GoToWebinar. Just some other things to note. We have another webinar coming up in April, and this is going to go a step further. We started talking about supply chain optimization. We're going to try to attempt to answer the question of when to optimize and when not to. And again, we're going to have this webinar as well as the webinars that we had previously on our website, so you can feel free to check out the recordings as well.
All right. Do we have any questions?
So while we wait to get some questions, I had a question of my own, Sujit, so maybe you can help me with this. For the slide where you had inventory projections showing in monthly buckets, can we apply this to a day-by-day planning type of scenario?
Yeah, I use months as an example, especially when it comes to things like rough cut capacity planning and a longer horizon. Month by month or a week by week bucket is usually considered good enough. If you are really doing this on a more near-term basis, let's say for the next 6 weeks, you would be considering the questions, considering the inventory at maybe a daily level or a twice a week level. So really, it's a question of what are you trying to do. The month based approach is quite popular for multiple reasons. It's easier to do, but also because a lot of the organizations, certainly the public businesses, they like to report inventory as month-end inventory. So where you are through the month is not as important in terms of your inventory as long as you end the month close to the target. So that is another reason why month by month is a very popular view. But certainly you can do it on a more detailed day-by-day basis.
Okay, so Rajiv will like to know, can the Arkieva tool do the inventory projection at at a day level with 5 to 6 SKUs on one production line with demand at daily interval?
Yes, like I said, it's a question. Whenever you go down to days, you are increasing the mathematical load on the model. And so the question you have to ask is, how many SKUs and how many machines and how many days are we looking at? So if you want to go day by day, but you want to look for next 18 months, I would caution against that because that's just too many days. If you have millions of SKUs and you want to look at day by day, I would probably again caution because that's now very detailed scheduling, not no longer planning. But the short answer is, especially with the parameters Rajiv suggested, 5, 6 SKUs, and if you want to project it day by day, those types of things are fairly common.
Okay. So the follow-up question from that is, can this generate day-wise production schedule, which would ensure targeted service level?
Yes, that would be the typical use of the supply planning tool, where you feed the target, and you feed your capacity limits and so on, as well as the day-by-day demand, and then based on that, it would say, here's what you need to make so that you're still within the target. There are other factors that it can incorporate as well. You know, you might have things like lot sizes and preferences and run rates, but you know, those are things that you can easily incorporate.
Thanks, Ajit. I think we don't have any more questions at this time. Thanks, Rajiv, for that question. I think it was very helpful. So at this point in time, we'd like to end the webinar. We want to thank you for spending some time with us today. We hope you have a great day. Thank you.
Thank you.